This next lab we're going to do with calorimetry is to find the specific heat of a metal object. So we have an element and it has a property called specific heat. That's the rate that it absorbs and changes temperature based on its mass and its identity. And what we're going to do is we're going to measure how it transfers heat with water. In order to do that, we're going to have to heat this metal up. We do that by boiling it in another beaker of water, and this will give us a temperature of the metal is about 100 degrees. And we will need to take that exact measurement. And when we put this in the calorimeter filled with water over here, what happens is that hot metal is now in cold water, and we will get a heat transfer. So we're assuming 100% heat transfer from the metal to the water. And we go back to our calorimetry concept here, where the heat that the water absorbs is equal to the heat that the metal gives off. So we have a 100% heat transfer there. The water, as usual, we can measure. If we have the water, we could measure inside our cup here the mass of the water using the density. The density is 1. We can measure the volume. The specific heat of water we know is 4.18. And the temperature range change of water is easy enough to measure with a thermometer. So we can put a thermometer in there as this reaction is taking place. But now we're going to do something different here. Since we know the heat that the water absorbed, we can also figure out the heat that the metal gave off. So we change that sign, and then we can get the heat of the metal. Now, in order to find the specific heat of the metal, what we have here is a separate MCAT equation. Okay, so we have the heat of the metal. We can figure out the mass of the metal. The specific heat of the metal is the thing we're trying to solve for, and we will need to find the temperature change of the metal. Okay, now this is hard because it's a solid object, so there's another principle at play here. It's still heat transfer, but we got to think about it a little more clever. And what we have here is now we're using our calorimeter, and we have two MCAT equations that are set equal to one another, and we can solve them like this. Now for the temperature of the metal, we have to have an initial temperature and a final temperature of the metal. So this is going to take a little bit extra thought. The initial temperature of the metal, since it's a solid, we can't just put a thermometer on it. That's not how our thermometers work. We don't have solid thermometers. We have liquid thermometers, aqueous solutions. But if we put this in another beaker and boil it, we can measure the temperature of that boiling water. And we know that if we leave it in there long enough, the metal will heat up with the water and they will be at the same initial temperature. So this is a separate container of water. This is not our calorimeter, but we just boil it to get an initial temperature. It's near boiling, and you'd have to measure it, it'd be about 98, 99 degrees. What's the final temperature of the metal? Well, it's actually the same as the final temperature of the water in your calorimeter, because if you put the hot metal in the cold water in your calorimeter, the metal is going to give heat to the water until you get to the same final temperature. So if we know the final temperature of the metal, it'll actually be equal to the final temperature of the water. They're the same. They're going to reach the same final temperature because of heat transfer. This is what we're going to be doing in the lab, and that'll help us find the change in temperature for the metal, and we can calculate the specific heat of the metal and then potentially identify it if we know what those properties are. Some of these problems in the book with this idea get very challenging because you kind of have to do this and solve them at the same time. If you ever have a problem that asks you to solve for the final temperature, because the final temperature of both are equal, there's only one final temperature, you would have to use this equation here and kind of expand them both at the same time, because there's one variable missing on both sides, but it happens to be the same variable, so you would have to combine like terms, and you could solve for the final temperature in a textbook problem or a homework problem using this equation, knowing that you'd have two separate MCAT equations and sort the data that way. But in the lab, we're going to be able to measure the final temperatures. You have all the water data, therefore you can calculate the specific heat of the metal.